Okay, you're going to have to bear with me on this one. I've been kind of prepping for this, and this is going to be a lot, especially since, I'm on a little white piece of paper and a little whiteboard and stuff. This is going to be kind of tough for me to do, so kind of bear with me as I do this. Some of it is going to be review. This is where everything comes together. Chemistry, motion and forces, everything comes together into this unit. Okay, so work, just as a quick review, work is getting something to move. Okay, we had a whole unit on that, with the cars going down the ramps and the whole bit. Energy is the ability to do work. Okay, so it takes energy to get something to move, right? Which again we went over. Potential energy is stored energy, and we spent a lot of time on this. Okay, so gravitational potential energy, that would be the cars going down the ramp. I had my little blue ball. I hold it up. It's got gravitational potential energy. I let it go. It moves. Okay. Elastic potential energy. I touched on that, but I have a rubber band. I have a little paper clip. Right. That's his potential energy, potential to move. Right. It shoots. Chemical. You can think of chemical as you have dynamite. You light the fuse. It explodes. You have a chemical reaction. It gets the rocks to move, and you can make your little tunnel and stuff. Kinetic energy is the energy for that something has that's moving. Right. So I have my little 9-volt battery there. I have my ball. It's moving. It moves the battery. Okay. So that's kinetic. Magnetic. We're not going to get to. Unfortunately, the last week I'm going to throw some magnetism stuff on there, or in this. But I have a magnet right here, and I have my little washer, and magnetic potential energy is the ability to get the washer to move. Okay. Electrical is where we're at. Okay, so electrical energy is a type of potential energy, and we can use gravitational energy as a way to describe it. And this was in the notes. I just want to explain briefly what the pictures meant in the notes. Okay, so here's my little drawing of what was in the notes, the tank up on top and a little water wheel and a little puddle down below. Okay, so this water tank, the water in this tank, because it is off the ground, right, it's off the ground, it's sitting in that's my little water tower. This has gravitational potential energy. It has the ability to fall down and move the water wheel. Okay? In electricity, this potential energy, this stored energy, would be called voltage. It's stored energy that can move through a wire. Okay? When I open this little valve, and we can call this a switch, which we're actually going to get to during the next section, that would be the switch. That would be what would control the water to go out or the electricity to move. So when I open this little valve, I would be opening the switch, and this water would start to move. Okay, and it would go down toward the wheel. This flow of water, or in this case electrons, if we're talking about electricity, this would be called the current, the electric current. Okay, now this wheel right here is going to keep the water, it's going to slow it down, it's going to keep it from falling right into the little puddle, the little pond. Okay, this water wheel, now this wheel is, right, it's going to move. It is going to do work, right? It's moving. Okay, so this would be the resistance of the flow of water. Okay, so right now we have everything we need to describe how electricity works. Okay, we have potential energy, stored energy, okay, which in this case would be, when we're talking about electricity, be voltage. Once this gate is open, this stored energy starts to flow, and that is called current. And whatever slows down that current is called resistance. Now, on the other pictures, it was a series of pipes and stuff. If I was to take this pipe and I was to make this pipe more narrow, if I was to squeeze the pipe, that would also add resistance, okay, which is going to be important for the next unit or next section. So this is also a type of resistance. Oh, let me turn off my email here. Okay. Okay. So that is also a type of resistance by squeezing the pipe. Okay. Now, in terms of batteries, where does this voltage and current and where does all this come from? Okay, this is I'm going to reset myself right here, and we're going to talk a little chemistry, okay, and we're going to talk about the batteries themselves. So here's my battery, okay, and if you look on a battery, and I hope you can see this, but you've seen it before, this little plus sign right here. Let me try turning the lamp on. Oh, look at that. Okay, this little plus sign here is the cathode. I don't know if you remember from the ionic bonding unit, but a cation is positive. The positive side of a battery is called the cathode. Okay, and the negative side is called the anode. An anion is a negative ion. The anode is the negative side. Now, why do they use ionic symbols and ionic names to name batteries? Because it's ionic. There's a ionic chemical reaction happening here. And this is how it works. So here's my battery. I'm going to make this really simple. Okay, so here's my positive end, and here's my negative end. And inside a battery, there's a border, usually made of lead, which is why you don't want to throw your batteries in the trash, because you'll end up lead poisoning the dump. But you have a battery, okay, and on this side, there are a bunch of negative ions. Okay, this would be the anode. Okay, oops, sorry. That would be the anode. Okay, and then you have a positive side, is the cathode. Okay, now this is not happy the way it is because it is uneven. You have a high concentration of negative ions on this side and a high concentration of positive ions on this side. Now, negatives are the only ones that can move. Okay, positive ions, protons, can't just jump out of the nucleus, right? But covalent or valence electrons move. So what you do is you take a wire and you connect the two ends, and these electrons say, yay, a way out, and they start moving through the wire to the other side. This flow of electrons from the anode to the cathode, flow of electrons, is called electricity. Okay, so I'm going to turn this lamp off. Let's see if that's terrible. Let me try that again. No, it's not too bad. Let me back it up. Okay, so let me skip my song here. It's a little funky. There we go. Okay, now this flow is called electricity. Okay, now this potential energy in the battery, this potential to move the electrons from one place to the other, that is the voltage. Voltage is the potential energy, chemical energy in this sense, the potential energy in the battery. The flow of electrons through the wire is measured with the current. And voltage is measured in voltage. Current is measured in amps or amperes, usually just abbreviated amps. And then if I was to put, right in here, if I was to put a little light bulb right here, here's my light bulb. Okay, there's my little light bulb. This light bulb is going to slow the electrons down, okay, and that's why it glows. It's a dam. It's bunching up the electrons behind it, and there's this push, and it gets hot because the electrons are trying to force themselves through. That's why it glows. But this would be the resistor, and that is measured in ohms. Now the abbreviation for ohms is omega. Okay, the abbreviation for current is I. Okay, and the why that is, I don't know. Voltage is measured in, oh no, yeah, no, that's right, I don't know. Voltage is measured with V. Okay, now you can figure out, or you can use math to figure out all of this stuff. And what we do is we use what's called Ohm's law. Okay, and this is Ohm's law. Let me do something real quick. Okay, so resistance, and you can put this in your notes because the equation is not in your notes. Resistance, this is what I would have done on the board in class. Resistance equals the voltage divided by the current. Now there are several ways you can write that. Okay, you can write R equals V over I. There's your current. Okay, the I is the current, right? You can also write it as omega equals V over I. Okay, that's the ohms, right? Now there's a trick. There's a trick to this, and I showed you this way early in the year when we were doing density. There's the triangle method. Okay, there's a triangle method. If you have a 3-variable problem, you can use this math triangle to make it easier on yourself. Okay, so I'm going to draw my triangle, and you can do this in your notebook too. Okay, like that. Okay, so resistance equals voltage over current. Okay, and the way this works is it gives you all the possible combinations. So if you're calculating voltage, it's R times I. Okay, if you're doing, well, let's say resistance equals V over I, and then current equals voltage over resistance. Okay, so there's all three. So voltage equals resistance times current. Okay, resistance equals volts divided by current, and current equals voltage divided by resistance. Okay, and our interactive notebook assignment is going to have you do some of these equations to practice those. But I also wanted to show you one of the labs that we would have done in class. Now I can only use what I have at my house, right? I have some equipment, but the most acidic fruit that I could find in my refrigerator was a strawberry. Okay, so The way that they make batteries is by putting acids in here. Okay, I don't know if you've ever heard there were acids in batteries, but there's acids in here. And during the last unit, during the last part, I had you do a lab where the higher the concentration of acid, the higher concentration of ions, the more electrically conductive it is. Okay, so inside a strawberry is citric acid. Okay, and I don't know if you knew that or not, but what we do is we have different metals in here, and metals dissolve, or acids dissolve metals, and we use that property of acid to conduct electricity. So what I have is strawberry, I have steel, which is mostly iron, and I have a copper wire right here that I took out of a bigger wire. And what I'm going to do, my little voltmeter here, okay, turn it on, and now we're going to have a pretty low voltage. I don't know if you can see that, but this is in 200 millivolts is the highest it'll go. A millivolt is crazy tiny. It's 1,000th of a volt, right? But I have a metal, another metal. One metal is going to give its electrons, and the other one's going to take, and that movement of electrons in that circle is going to produce an electric current. And you can't see that there. I'll try to do this with one hand. That's not working. And it is touchy because it's a strawberry. There we go. I don't know if you can see that, but I'm actually getting a lot. About 50 millivolts or so. It's not going to be very consistent because, well, it's a strawberry. Okay, but it does produce a current. Okay, so the electrons from one metal are going to the other. How are the electrons being released? There's acid in the strawberries that's actually dissolving the metal. And that's how batteries work. So if you had like a 9-volt battery, okay, that border between the positive and the would be lined up down the middle. This border is down the center right here. And in this battery, there's a border right in the middle separating the two ions. And when everything, one more thing. When you have your battery, and you have your border, and you have your negative anode and your positive cathode, once all the chemical reaction is done, once you have the same number of negatives on one side as the other, the battery's dead. And then you have to replace it with a fresh battery with more potential energy in it. So that's how it works. Your interactive notebook assignment is going to be on Ohm's law. Okay, we're probably going to be doing a FET. I'm still working on that. And then you'll be calculating the voltage in amps and resistance for that. Okay, I hope that made sense. During the next section, we're going to be making circuits and studying how circuits actually go together and how all of this connectivity works. Okay, so if you have any questions, let me know. I'd like to hear from you, see how you're doing. But otherwise, go ahead and watch the other video that explains how to do the interactive notebook assignment. Okay, thanks for watching. Okay, bye-bye.